Okay, so this lesson is on simplifying radicals, and for us, the radicals we're working with are square roots. And so this is very important for the quadratic formula and solving quadratic equations. So our warm-up is just about solving quadratic equations. And so far we have two ways to do that. One way is Desmos, so I'm going to show both. And so using Desmos, we would just type in the left-hand side of the equation, the quadratic equal to 0. And so 2x squared plus 2x minus 4. And so our solutions are -2 and +1. Now, if you don't have a calculator, we have to do this by factoring. And so to factor, we need, well, actually, our a value is not 1. And so luckily, that is a GCF. And so we can divide all of these numbers by 2 right off the bat to simplify it. And so that would leave us with x squared plus 1x minus 2. And then we just need two numbers that multiply to -2, but add to +1. And those numbers are +2, -1. So our factors would be x plus 2, x minus 1. And so we would set each factor individually equal to 0. And then in this case, we would subtract 2 to get x equals -2. In this case, we would add 1 to get x equals 1. Over here, we don't have a 0 on the right, so our first step is to move the 4 by subtracting it, giving us x squared plus 3x minus 4 equals 0. Don't combine it because they're not like terms. And then this one's really easy to factor. We need two numbers that multiply to -4, but add to +3. And so that would be +4, -1, meaning this factors to x plus 4, x minus 1. Set each one equal to 0. In this case, we subtract 4 to get x equals -4. In this case, we add 1 to get x equals 1. And then we could also graph the x squared plus 3x minus 4, and we end up with -4, +1. Over here, we need to move the 16 to give us x squared minus 16. And so we need two numbers that multiply to -16 but add to 0. That would be +4 and -4. And so when we set them equal to 0, we would get x equals -4, x equals +4. And so you could also write that solution as +(-4) using that symbol. We're going to use it a lot when we get to the quadratic formula. So it just means positive and negative, plus or minus. Now, today we're just talking about square roots. And so perfect squares are numbers that a number times itself would give you that number. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. And so these are all considered perfect squares. It's suggested if you're honors to memorize these because it's very helpful to have them memorized. Some numbers that are not perfect squares are 2, 10, 3, 7, 6, because nothing squared would give you 2. A lot of people mistake 200 for a perfect square or 20 for a perfect square. They're pretty numbers, they're even numbers, but nothing squared would give you them. If you were to try to square root them, you would not get a pretty number. And so perfect squares have to have a whole number square root. So for example, 100 is one of our perfect squares, and 10 would be its square root because 10 squared gives you 100. So what that looks like is if we were to use square root function of 100, it would give us 10. Likewise, 25 is a perfect square, and 5 would be its square root. So if I were to square root 25, it would give me a 5. 9 is a perfect square because 3 squared would give you 9, so that 3 is its square root. So square root of 9 equals 3. 16 is a perfect square, and 4 is its square root. So square root of 16 equals 4. 49 is a perfect square, and 7 is its square root. So square root of 49 equals 7. Okay, and so these tend to come up on PSAT and SAT where a calculator is not allowed. And so they want to see if you can simplify square roots without a calculator. And so in the case of number 1 here, simplifying the square root of 100 would just give us 10. Simplifying the square root of 4 would just give us 2. And then if you don't know that the square root of 400 is 20 without a calculator, what you can do is you can break up that 400 into a product of 4 times 100. And so the reason why I'm breaking it into a product is because you can actually break up products into their own individual square roots. This only works for products, not plus signs. So because there's times, we can break these up. And then I know the square root of 4 is 2, and I know the square root of 100 is 10, and then 2 times 10 would give me 20. So we use the property that square root of a times b is the square root of a times square root of b, just saying that we can break up square roots. And so you're going to see how this comes into play when we start simplifying non-perfect squares. And so for this expression, square root of 9 is 3, and then square root of 2 is not a pretty number. If I show you that in Desmos, square root of 2 is an irrational number. Very ugly decimal, can't be written as a fraction. So we don't want to round it, and so we just leave it like that. And so 3 square roots of 2 is the best we can do for that simplified expression. Over here, we know square root of 25 is 5, and square root of 49 is 7. And so 5 times 7 is 35. And 35 would be our simplified answer. Okay, over here, square root of 18, that is not a pretty number. It's an irrational number. And so we can't simplify it into a whole number, but we want to simplify the radical. And so just like with fractions, we would simplify 3/6 to 1 over 2, we want smaller numbers to work with. And so what I can do is I can break 18 into 9 times 2. The reason why I'm choosing 9 times 2 instead of like 3 times 6 is because 9 is a perfect square. 3 and 6 are not. So you're looking for a perfect square factor. So that way when I break them up into their individual square roots, I can simplify that square root of 9 to 3 square roots of 2. Okay, and then I always like to check my work. Square root of 18 is that ugly decimal. If I type in 3 square roots of 2, it's the same ugly decimal. And so Desmos won't simplify square root of 18 to 3 square roots of 2 for you. They'll always just give you the decimal. And so it's up to us to look for those perfect square factors. And so what you can do to find those perfect square factors is you can actually make a factor tree and just use any factors you want to get to the prime factors. So that's what we're going to do for the 80. Instead of hunting for perfect squares, I just like to start with 2 if it's an even number, 2, and then since it's prime, I'm going to circle it. Then we're going to break down the 40 into 2 times 20. And then we're going to break down the 20 into 2 times 10. And then 10 is 2 times 5. And 5 is prime. You can start with any 2 factors you want. You can do 8 and 10 for 80, 5 and whatever that is. You're going to have the same prime numbers that are circled in the end. Okay, and so what you do with those prime factors is you go ahead and make your square root. That's called a radical. And then you're looking for pairs. That means they were a perfect square factor. And so here I've got a pair of 2's. And so I'm going to cross those off and write the 2 one time outside the square root. Think of it like matching socks. Once you find a matching pair, fold them into 1 and then put them outside the laundry basket. And so here I've got another pair of 2's, so I'm going to fold them into 1 and write it outside the basket. And you're going to put a time sign between any other numbers there. You're going to multiply them in the end. You don't want it to look like a 22. Okay, and so here I have a 5 that doesn't have a match. So if it doesn't have a match, just like with the sock without a match, you're just going to put it right back in the basket, and hopefully one day you find its match. And so our final answer, we would multiply those to get 4 square roots of 5. Okay, and so we can check our work. Square root of 80 and 4 square roots of 5. Those are equivalent. Same ugly decimal. Only 4 square roots of 5 is much simpler. The idea is you want the smallest number possible inside the radical. Okay, and so for square root of 294, you can go ahead and try to square root it to see if it's a perfect square. It's not, that's an irrational number. And so then I would go and make the factor tree. Okay, and so 294 is an even number, so I'm going to start with 2. And then 294 divided by 2. So 2 times 147. 147 is not an even number, so I'm going to try 3. And 49. And then I recognize that 49 is 7 times 7. And 7 is a prime number. Okay, and so then we make our radical and start matching socks. So we've got a pair of 7s, so that can go outside the basket. And then 2 doesn't have a match, and 3 doesn't have a match. So those are going to get multiplied under the radical. And so this would simplify to 7 square roots of 6. And then we can check our work. 7 square roots of 6. Same ugly decimal as the square root of 294, only this is much simpler. Okay, and so now we're at square root of 648. We can try it, see if it's a perfect square. It is not, so we're going to make a factor tree for the 648. It's even, so 2 times 3, 24. And then 324 is even, so we can divide that by 2. And then 162 is still even. Then from here, you may recognize that 81 is 9 times 9, but keep going until you get to all your primes. Okay, and so I've circled all the prime factors. That's as far as we can go with this tree. And so now we can make our square root and start matching socks. And so we've got a pair of 2s. We've got a pair of 3s. We've got another pair of 3s. And then we have a 2 that doesn't have a match. Okay, and so 3 times 3 is 9, times 2 is 18. And so 18 square roots of 2 would be our final answer. And we can check to make sure they're equivalent. And they are. Okay, and so this back page, we're going to post the key, and so I would recommend you try all of these and then check your answers with the answer key. And then some problems we did in class to get us ready for quadratic formula looked like this. And so the idea for this is a number under a radical cannot interact with a number outside the radical. Treat that radical like prison. He can't interact with this 2 because he's in prison. And so what we have to do is we have to simplify that square root of 76 first. So I'm going to come over here and make my factor tree for the 76. And so that would be 2 times 38. And then 2 times 19. And then 19 is actually prime. Okay, and so when I make my radical, 2 would get to come outside the radical, but that 19 doesn't have a match. And so he would stay inside the radical. And so this expression simplifies to 2 square roots of 19 from that 76. And then we still have that 2 on bottom. Okay, so I rewrote the square root of 76 as 2 square roots of 19. And now the 2 times square root of 19 cancels with this division by 2. These outside numbers are allowed to interact. And so that would leave us with just the square root of 19. And so this would be our final answer. And so I have the answers at the bottom here. Okay, so same thing for this one. We need to simplify this square root before we can divide by 6. And so 72 is even, breaks up into 2 and 36, 2 and 18, 2 and 9, 3 and 3. And so we have a pair of 2s, and we have a pair of 3s. And then we have 1, 2 that stays behind. And so this simplifies to 6 square roots of 2. And so the numerator is just 6 square roots of 2, and then we still have that division by 6. So the 6 square roots of 2 came from the square root of 72. And now the 6's can cancel out, leaving us with just the square root of 2. And that's what we got here. Okay, I'm going to skip this one and let you do it. For this one, there's a negative outside. You can ignore that for now. We're just going to focus on simplifying this radical. So I'm going to make my factor tree for 32, which is 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, and so lots of 2's. 2 and 2, another 2 and 2, and then we have a 2 left behind. And so this would be 4 square roots of 2. And so when I come back to my expression, I still have that negative, and then we have that 4 square roots of 32, and then we still have the over 2. So the 4 square roots of 2 came from the original square. Oh, I wrote 32. Just 2. Yeah, 4 square roots of 2. And so now this negative 4 over 2 can simplify to negative 2. And then we still have that square root of 2 that's in prison that can't interact with anybody. And so that's why our final answer was negative 2 square roots of 2. For this one, we're going to simplify square root of 76. So that would be 2 and 38, 2 and 19. So the 2's pair up, the 19 stays behind. And so 2 square roots of 19 is my new numerator, and it's still over 4. And so we can simplify 2 over 4 to 1 over 2. And so we typically leave the 1 off for our final answer, which is how they wrote it. All right, so now we have this plus or minus sign. That's what the quadratic formula looks like. And so we're going to have to simplify stuff like this. And so you have a negative 6 in front of the plus or minus. And so you can treat this part of the fraction separately. And then you have your plus or minus, which just keep writing the plus or minus. You're not going to do anything with that yet. And then we have the square root of 76 over 2, which is just like the examples we were already doing. Okay, and so I recognize negative 6 over 2 is just negative 3. So my final answer is going to have that negative 3 plus or minus whatever we get from this expression here. And so 76 breaks into 2 and 38, 2 and 19. So that's 2 square roots of 19. And it's still over 2. And so before we commit to our final answer, we need to simplify even further by canceling those 2's. And so our final answer would still have that negative 3 and still have the plus or minus, and then the square root of 19, which is what they got. Okay, so same idea here. If you want, you can go ahead and break these up. And so negative 2 over 2 plus or minus square root of 56 over 2. Okay, negative 2 over 2 is just negative 1 plus or minus, and now we simplify the square root of 56. So 56 is 2 and 28, and then 2 and 14, 2 and 7. So we have one pair of 2's, and then a lonely 2 and a lonely 7. So 2 square roots of 14 is how that simplifies. And now we can cancel these 2's. And our final answer would have the negative 1, the plus or minus, and the square root of 14. All right, last one, hardest one. We have negative 8 over 4. We have our plus or minus. And then we have our square root of 8 over 4. Negative 8 over 4 is just negative 2, plus or minus, and then we can simplify our square root of 8 before we divide. Okay, so 8 breaks into 2 and 4, 2 and 2. So we have one pair of 2's and one lonely 2. And so 2 square roots of 2 is the new numerator. And then before we commit to our final answer, we can simplify 2 over 4 to 1 over 2. And so our final answer would have the original negative 2 plus or minus. And then we're going to leave that 1 invisible and just write the square root of 2 over 2, which is how they wrote their final answer.